MA 19201 Engineering Mechanics. Welcome you all to the online class. Unit 5 Friction, Module 1 Friction and its types, limiting friction, coefficient of friction and angle of friction, Coulomb's law of dry friction, impending motion, angle of repose. What is friction? Friction is a force between two surfaces that are sliding or trying to slide across one another. For example, when you try to push a toy car along the floor. Friction always works in the direction opposite from the direction of the object which is moving or trying to move. It always slows a moving object down. You can see from the image, the motion is acting in the forward direction, so the friction will be happening in the opposite direction of motion. A simple definition of friction: the opposing force which acts in the opposite direction of the movement of upper body is called friction force or simply friction. You consider a block here. A block is moved by applied force. The applied force is a pushing force so that the block moves in the forward direction. So the friction happens in the opposite direction of motion. Free body diagram. The block will have its own self-weight SW. It is acting towards the center of gravity self-weight, and self-weight is balanced with a normal reaction. So the applied force is supplied on the block here. So motion takes place in the forward direction. So friction will take place in the opposite direction of motion. So motion is here, friction opposes. Types of friction. Generally, we classify the friction into two categories. One is static friction and another is dynamic friction. Static friction. When the body is at a rest condition, then the friction force is said to be a static force or static friction. Static friction is a friction that occurs when the surface in contact area or rest. Example, a book resting on a desk, a potted plant sitting on a sidewalk. You can see from the picture. Dynamic friction. When the body is in motion condition, then the friction force exerted by the body is called dynamic friction. Static friction happens in a resting body, whereas dynamic friction happens in a motion body. So dynamic friction is classified into three types. One is a sliding friction, number two rolling friction, number three pivot friction. Sliding friction. When a body slides over another body, then the friction force exerted by the body is called as sliding friction. Rolling friction. A body which has balls or rollers and rolls on the another body, then the friction force exerted by the second body on the first body is called rolling friction. Pivot friction. The friction force experienced by a body due to the motion of rotation, as in case of footstep bearings. Sliding friction. Sliding friction is friction that occurs when a solid surface slides over one another. Example, writing pencil point and paper, combining your hair surfaces of comb and strands of hair. So you can see from the example, a pen slides over on a notebook. Rolling friction. Rolling friction is the friction that occurs between surfaces in motion in which one of the surfaces is a wheel or a roller or a ball. Example, riding a bike, tires and ground will have friction. Some other types of frictions are as follows. Number one is a dry friction. Friction that happens between two unlubricated is called as, or dry surface is called as dry friction. Lubricated friction. Friction between two lubricated surface is called as a lubricated friction. The lubricated friction is classified into two types. One is a greasy friction, another is fluid friction. When there is a very thin layer of lubricant between the surfaces, then it is called as a greasy friction. When we introduce a thick layer of lubricant between two moving surfaces, then it is called as fluid friction. Fluid friction. The force that tries to slow object down when they move through a liquid or gas, it is known as a drag or air resistance. All gases and liquids are fluids. An airplane and a swimmer both experiences fluid friction. So the motion is opposed by fluid. So a swimmer force is balanced or opposed by the fluid. Limiting friction. The maximum frictional force that can be developed at the contact surface when the body is just on the point of moving is called a limiting friction. That is, the applied force is balanced by the friction force. That is called as limiting friction. Angle of friction. The angle between a normal reaction and the resultant force. The angle between the normal reaction and the resultant force is called as angle of friction. Coefficient of friction. The ratio of limiting friction and normal reaction is called as coefficient of friction. Mathematical notation: mu is equal to F by N. Mu refers to coefficient of friction, F refers to the frictional force or limiting friction, N refers to its normal reaction. That is, mu is equal to F divided by N. Angle of repose. With the increase in the angle of the inclined surface, the maximum angle at which the body starts sliding down is called angle of friction. So at particular angle of inclination, the object, the block, tends to slide down. So that moment is called as angle of repose, or that angle is called as angle of repose. Laws of friction. Laws of static friction. The friction force always acts in a direction opposite to that in which the body tends to move. The magnitude of friction force is equal to the external force, that is, F is equal to P. The ratio of limiting friction and normal reaction is constant. Therefore, mu is equal to F by N. Mu is equal to F by N. The friction force does not depend upon the area of contact between two surfaces. The friction force depends upon the roughness of the surfaces. Laws of dynamic friction. The friction force always acts in the direction opposite that in which the body is moving. The ratio of limiting friction and normal reaction N is constant and it is known as coefficient of friction mu. For moderate speeds, the friction remains constant, but it decreases slightly with the increase of speed. Impending motion. The state of motion of a body which is just about to move or slide is called impending motion. When the maximum force is attained and if the applied force exists the limiting friction, then the body starts to slide or roll. This state is called impending motion. Unit 5, Friction, Module 2. Friction in simple contact surfaces, friction of a body lying on an inclined plane, and ladder friction. So now we are going to learn about the friction in simple contact surfaces. Consider a block. A block is placed on a surface. The surface may be smooth or rough. So a block is placed on a surface. So the block will have a self weight W. Again, the self weight is balanced by normal reaction. If we want to move the block, then we have to apply the force. This will be applied force, and friction will happen in the opposite direction of motion. So friction will act here. Similarly, you can see the second figure. A block is kept here. Block is resting on a surface. The block has a self weight W. The self weight is balanced by normal force. If we want to apply some force, now a pulling effect is here. So force is applied here. Therefore, the block will move in this direction. So friction will happen in the opposite direction of motion. Numerical problem. A body of weight 100 Newton is placed on a rough horizontal plane and pushed by a force of 45 Newton as shown in the figure A, B, C. to just cause sliding over the horizontal plane. Determine the coefficient of friction in all the three cases. So case 1, and consider the figure A. Figure A is here. Step 1, draw the free body diagram. So the block is resting on the surface. The surface is a rough surface. So a block is resting on a surface. The block self weight is 100 Newton. So W is equal to 100 Newton. The self weight is balanced by normal reaction. So applied force is shown here. So applied force is here. The applied force is 45 Newton. So friction force will happen in the direction opposite to the motion. So applied force here, friction will act as an opposing force. Now apply the equilibrium condition, that is sigma h is equal to 0 and sigma v is equal to 0. So sigma h is equal to 0, take all the horizontal components, that is 45 minus Fm is equal to 0. Therefore Fm, that is limiting friction, is equal to 45 Newton. Similarly apply sigma v is equal to 0, that is normal reaction is balanced by the self weight, that is Nr is equal to 100 Newton. So we have to find the coefficient of friction. We know the mathematical relation mu is equal to F by N, or limiting friction to its normal reaction. So the coefficient of friction is 0.45. Similarly, case 2, in previous case there was a pushing effect. Now here there is a pulling effect. The pulling effect is made with some inclination. That inclination is 25 degree. So draw the free body diagram. A block is placed here. Self weight is 100 Newton. It is balanced by normal reaction. The pulling force is resolved into two components, horizontal component and vertical component. So the motion takes place here. So friction takes place in the opposite direction of motion. Now apply the equilibrium condition. Sigma h is equal to 0. Sigma v is equal to 0. And find mu. So after solving the forces, we'll get the coefficient of friction is 0.503. Case 3. Case 3, there is a pushing effect in this direction. Previous case there was a pulling effect. Now it is a pushing effect. So figure 1, that is we are going to consider the block. Self weight is 100. It is balanced by normal reaction. So it is balanced by normal reaction. So the object is pulled in this direction. So this object is balanced by the frictional force. Now apply the equilibrium condition, that is sigma h is equal to 0, sigma v is equal to 0, and we know the mathematical relation mu is equal to Fm by Nr. By substituting the values, we can find the coefficient of friction as 0.342. Friction of a body lying on an inclined plane. In previous case, the block was lying on an horizontal plane. There was no inclination. Here there is an inclination angle. The angle is alpha. The block is placed on an inclination. So the block will have a self weight W. So due to inclination, the block will gain an inclination. So the weight of the block is resolved into two components. One is horizontal component, that is horizontal, as well as vertical reaction. The self weight is balanced by the normal reaction. So due to inclination, due to this angle inclination, the block tends to slide down. So the friction happens in the opposite direction. So this plane is happening in the absence of if the plane is smooth, there will not be any friction. If the plane is rough, there will be a friction. A block of weight 150 Newton is resting on a rough inclined plane as shown in figure. Block is tied up by a horizontal string which has a tension of 50 Newton. Find number 1, the frictional force on the block, the normal reaction of the inclined plane, the coefficient of friction between the surfaces of contact. So a block is placed on the inclination. The inclination angle is 30 degree. The block weight is 150 Newton. The block is tied by a string or a tension. The tension is 50 Newton. Now we are going to draw the free body diagram for the block. So take the block is having a self weight is 150 Newton. Due to inclination, it is based on some angle. The weight is resolved into two components, one horizontal component as well as vertical component. That is 150 is resolved into two components, that is 150 sin theta and 150 cos theta. So here a tension is acting here. Again, tension is based on some inclination. Tension is based on the inclination 30 degree. Again, the tension is resolved into two components, that is horizontal as well as vertical. So 50 cos 30 and 50 sin 30. Now we have to locate the friction. So since the block is kept on an inclination, the object tends to slide down. Due to inclination, the block will fall down or slides down. So the motion is here. So the friction will be taking place in the opposite direction. The block will fall down. So we are having a friction in the opposite direction. That is F. Now we are going to resolve the problem by applying the suitable equilibrium condition, that is sigma h is equal to 0, sigma v is equal to 0. By resolving, we can find the coefficient of the friction, that is mu is equal to Fm by Nr. Find Fm and Nr by resolving. By resolving the horizontal plane, we get F. Will be getting F as 31.7 Newton. By resolving the vertical force, that is sigma v equal to 0, we can find the normal reaction Nr equal to 154.9 Newton. So substitute in the coefficient equation, that is mu equal to Fm by Nr. Therefore coefficient of friction is 0.204. Ladder friction. A ladder is a device used to climb on the wall. The ladder is made of wood or iron. There are two long pieces in the ladder, to which many small cross pieces are called rungs, are connected at equal distance. If the ladder is uniform throughout its length, then the center of gravity of the ladder will be at the midpoint of it. So a ladder is here. The ladder will have a self weight which will be acting at the center point. So the ladder is placed between a between a wall and a floor. So consider the ground floor, consider the wall, and you are going to place the ladder. So the ladder touches the floor as well as it touches the wall. So the ladder will have a center of gravity due to its self weight. Suppose if a man is standing on the ladder, so consider M as a man standing on the ladder. The ladder will have an angle of inclination, it forms a triangle. So the inclination is theta. So this is the self weight of ladder and this is the self weight of man. Now the ladder is touching at point A. Consider this point A and consider this as point B. The ladder is touching at point A. So this point is balanced with a normal reaction, that is normal reaction by the floor, and it touches the point here. This is the normal reaction of point on wall. So you can see from here, this is the floor and this is the wall. The ladder is touching at point A and ladder is touching at point B. So normal reaction will be acting in the, or normal reaction acts to balance the ladder point, that is Na, and point B is balanced by the normal reaction Nb. The ladder will have its self weight W. So here at point A, the ladder, when a man stands on the ladder, find the reactions taking place at point A and point B. At point A, the ladder will tend to fall or tend to move in this direction. Therefore, friction will act in the opposite direction. Again, the ladder may tend to move downwards and friction acts in the opposite direction. Therefore, coefficient of friction mu A is equal to F by Fa by Na. Similarly, coefficient of friction at point B, mu B is equal to Fb by Nb. Equilibrium, you can apply the equilibrium condition, that is sigma h is equal to 0, sigma v equal to 0, and moment is equal to 0. We know the friction force, that is F is equal to mu into normal reaction. A uniform ladder of weight 1000 Newton and of length 4 meter rests on a horizontal ground and leans against a smooth vertical wall. The ladder makes an angle of 60 degree with the horizontal. When a man of weight 750 Newton stands on the ladder at a distance 3 meters from the top of the ladder is at the point of sliding. Determine the coefficient of friction between the ladder and floor. So consider the floor region, wall region. A ladder is placed. Ladder is touching at point A, ladder is touching at point B, A is touching the floor, B is touching the wall. So normal reaction NA, normal reaction for wall is NB. The self weight of ladder is 1000 Newton. The total length of the ladder is 4 meter. The angle of inclination of the ladder is 60 degree. Now a man is standing on the ladder, so his position is 3 meter from top. The total length of the ladder is 4 meter, but a man is standing from the top at a distance of 3 meter on the ladder. The man weight is 750. He is acting towards gravity. Now apply the equilibrium condition, that is sigma h is equal to 0, sigma v is equal to 0, and we are going to take the moment that is sigma m is equal to 0 in order to find the coefficient of friction. So by resolving the vertical force, we can get the normal reaction of floor as 1750 Newton, and apply the horizontal condition, that is sigma h is equal to 0 in order to find the normal reaction of wall. So we have already found the normal reaction of floor, that is 1750 Newton. We have to find the normal reaction of floor. To find the normal reaction of floor, we have to take moment. So we're going to split the ladder into 3 simple triangles. So region 1 is ACE. ACE. If make this a small triangle. Similarly, next triangle ADF. Next triangle ABG. So find the unknown distance, that is the unknown distance are BG is unknown, AF is unknown, A is unknown. By using the triangle, we can find the distance of BG, AF and AE. By substituting the distance, we can find the normal reaction for the wall, that is NB. Therefore MB is equal to 396.9 Newton. So we have found the normal reaction of floor, normal reaction of wall. And next step, we are going to find the coefficient of friction. We know that mu is equal to F by NR. That is friction force by normal reaction. By substituting the known values, we can get the coefficient of friction as 0.226. Thank you.